Swish, swoosh, bang to bang, and I'm working on my body like a chimpanzee. Zang, I'm the only player with the big prize. I'm the only player with the big brown eyes. Roll like a train in the middle of the block. You better call the cops, I'm playing on the clock. Yo, swag, swag, working on my swag. Venom in the booty and I got mine. Yeah. Still run so higher. Oh, we know it's higher. 5, 4, 3. Yeah, wham, bam, super tramp. And I tipping up my hat while I boost the fans. And I hover up top, can you feel the noise? All the girls scream now cause they want the boys. Yo, making all the clouds looking like a big joke. When I run so fast and I sing so low. And you never wanna mess with me, you just listen me. I just set me free, so just stop. We cool, we hot, we freshin'. We know we all confessin'. My bling bling catch your eye. Better pull up those shades when I'm walking by. So give a bitty high five on the street. Next summer when I fly by, feel the heat, cause I'm on the roll. I lose control, want you to know it's how it goes. Still run so higher.
In this video, we're going to begin to study polygons, and in the first unit, we're going to learn how we're going to use triangles to help us determine angle measurements in any kind of polygons. So this is really important. The sum of the degrees in any polygon can be determined by the number of triangles that it can be drawn within the polygon. So what does this mean? Let's look at this table below here. On the left-hand side, I've specified what kind of polygons we have here, and here you have a picture. So obviously this is a triangle, therefore I've got 3 sides, and I've got just obviously one triangle, right? 3 sides, 3 angles, but one triangle. And we also know, we've known this for a while, that the total sum of the interior angles in a triangle is 180 degrees. Okay, and the next thing we're very familiar with is quadrilateral, and here I've had drawn a rectangle, and notice that if I cut it diagonally, right, I have 2 triangles in a quadrilateral, and quadrilateral also, obviously is 4. So I've got 4 sides. And we also know that the total sum of quadrilaterals is 360. The easiest way to determine this is with a rectangle because every corner is 90 degrees, or a square would help us with that too. Okay, so now let's look at this pentagon. Pentagon is 5 sides. And if you see the dotted line I drew, I created 3 triangles within the pentagon, and therefore I should have 540 degrees. Okay? Let's stop for a moment. Did you notice that from triangle to quadrilateral to pentagon, my number of sides for each figure increases by 1, 3, 4, 5, right? And the number of triangles also increases by 1, 1, 2, 3. Also, the number of sides, the difference between the number of sides and the number of triangles, 3 minus 1 is 2, 4 minus 2 is 2, 5 minus 3 is also 2. So let's keep going with the hexagon. Hexagon, obviously, I've got 1, 2, 3, 4, 5, 6 sides. And if you connect the vertexes, you have 4 triangles. Therefore, it should be 720 degrees. Now, why do I say that? Again, let's go back to the sum of interior angles right here. when I have one triangle, I have 180. When I have two triangles in a quadrilateral, I have 360. Obviously, with three triangles, the total interior angle has to add up to 540. And now that I have 1, 2, 3, 4, that's simply 4 times 180 degrees. That's how I got 720, right? So by the same token, if I finish this table, this one I should have 7 sides. 7 minus 2, even though I don't have the picture, we should have 5 triangles in there. 5 times 180, I should have 900 degrees. For octagon, I should have 8 sides. Nonagon is 9 sides, and decagon obviously is 10 sides. So I'll leave you guys fill out this part. Again, number of triangles is total number of sides minus 2. Number of angles, interior angles of a polygon, is the number of triangles within the polygon multiplied by 180 degrees. So from there we can draw the conclusion: if n represents the number of sides and the sum of the interior angles, then the sum of the interior angles can be found using s equals n minus 2 times 180. In other words, if I have triangle, my n is 3. 3 minus 2 times 180 is 180. If I have a rectangle or quadrilateral, my n is 4. 4 minus 2 is 2. 2 times 180 is 360. And s represents the sum of the interior angles. And here is another one. An interior angle of a regular polygon. A regular polygon is one in which all sides are equal. Therefore, all angles must be equal as well. To find the measure of an interior angle in a regular polygon, we just use S, which is the total, the sum of the interior angles divided by the number of sides. In other words, if I have 360 degrees and I have 4 sides in a rectangle, 300 divided by 4, 360 divided by 4, I should have 90 degrees. That's the interior angle of a regular polygon, right? So now let's look at some practices right here. Number 1, find the sum of the interior angles of a 15gon. So if I use the formula of s equals n minus 2 times 180, my n is 15. Therefore, it's 15 minus 2 times 180. Your total angle, interior angle, the total sum of the interior angle is 2040 degrees. And number 2, find the sum of the interior angles of a 21gon. Again, n equals 21. So the formula is s equals n minus 2 times 180, which is 21 minus 2 times 180. Use your calculator. You should have 3,420 degrees. Number 3, what is the measure of each interior angle of a regular pentagon? Remember, pentagon is 5, right? And regular meaning all 5 sides are exactly the same. So my n equals 5. I still use n minus 2, which is 5 minus 2. And I should have 540, right? So that's the total sum of the interior angle. But I'm looking for each interior angle of a regular pentagon. And again, now we're going to use s equals, Now we're going to use the formula where S divided by N. So the total interior angles is 540. My N is 5. My final answer should be 108 degrees. Number 4, what's the measure of each interior angle of a regular 18gon? So my N equals 18. I first have to find out my total sum of the interior angle would be 18 minus 2 times 180. And that should give me 2,880 degrees. Once I find the total sum, I just use the total sum of the interior angles divided by the number of sides. So that way I get each angle is exactly 160 degrees. Okay? I do want you to pay attention. See, here we're finding the sum of the interior angles. Here we're finding the measure of each interior angle. So the keyword is very different. And 3 and 4 obviously is a two-step problem. Here is the exterior angles sum. Exterior angles are always supplementary to their adjacent interior angles. Remember, supplementary meaning everything adds up to 180 degrees. So let's see. If we have 79 degrees here, this exterior angle would be 101 because it's 101 plus 79 is 180. And this exterior angle here would be 119 degrees. And this angles here would be 180 minus 40, which is 140 degrees. Now, if I add the 3 together, 119 plus 101 plus 140, voila, it comes out with a nice even number of 360 degrees. Okay? So that's a triangle, right? Let's look at quadrilateral. So if I find this, it would be 56 degrees. Over here it would be 180 minus 76, so that's 104. Over here, 180 minus 89, it would be 91 degrees. And this angle would be 109. And if you add all 4 angles together, all 4 exterior angles together, you would have also 360 degrees. That's really nice, isn't it? That even though this is a quadrilateral, this is a triangle, once we find the exterior angles and add them together, they all add up to 360 degrees. Now let's look at a pentagon. I would have 180 minus 98 would give me 92 degrees. Over here, 180 minus a 21, I would have 59 degrees. Over here, 180 minus 87, I would have 93 degrees. Over here, 180 minus 130, that's easy, 50 degrees, mental math. And this one would be 76 degrees. Now, if you add everything together, I have 92 degrees plus 92 degrees plus 59 degrees plus 93 degrees plus 50 degrees plus 76 degrees. Punch it into your calculator, and guess what? You have 360 degrees. Okay? I will leave the last one for yourself to prove, but I can guarantee you that if you do your math right, your answer should come out to be 360 degrees. So this leads us to a really nice, simple conclusion that the sum of the exterior angles of any polygon did I spell that one right? Polygon is obviously 360 degrees. It does not matter how many gons you have, how many sides your figure has. The exterior angles all add up to 360 degrees. So that's really nice. Let's look at some quick practices here. What's the measure of each exterior angle of a regular hexagon? Now, hexagon, I think, has 6 sides, right? And we know the exterior, the total sum adds up to 360. And since I have 6 sides, I should have each one of the exterior angles should measures up to 60 degrees. Number 2, what's the measure of each exterior angle of a regular 24 gon? So n is 24, and same thing, 300, because it's a regular polygon, is 360, because it's exterior angles divided by the number of sides. You should have 15 degrees. Okay, notice I want you to do a comparison between the sum of interior angles versus the sum of exterior angles. In this case, the sum of exterior angles, it's much easier because it just, whatever it is, it adds up to 360. Whereas the sum of the interior angles, depending on the number of sides it have. Because once we find out the number of sides of the polygon, that number minus 2 give me the number of triangles I can have. And then I use the second number, the number of triangles, multiplied by 180 to find the sum of the interior angle. Okay? Last 2 questions. The exterior angles of a regular polygon measures 12 degrees. How many sides does the polygon have? So sides is unknown. N is unknown, right? But we know that each one of them measures 12. So if I use the number of sides multiplied by 12 degrees, I should have the total of 360 degrees. Now, if I divide n on both, divide 12 on both sides, n should come out to be 30. This is a 30 gon. Last one, if the exterior angle of a regular polygon measures 40 degrees, so it's a regular polygon, each one of them measures to 40. How many sides? Same question. So I don't know n. Total number of sides is n. N minus each angle would give me the total, and the total I know has to be 360. And obviously, in this case, n has to equal to 9. Okay? So that's this is a really nice introduction that ties triangles together with polygons, and you can see now that you know everything about triangles, that can lead to a lot of new knowledge about polygons. All right, guys, I'll see you in class. Bye-bye.